I'm going to go over the test review for our test over exponentials and laws of exponents. Number one, a part of the exponential function f is shown on the grid. Write the domain and the range. Remember, domain is x and range is y, using the answer choices provided. So you want to pay attention to the fact that there is, in fact, an arrow. So we really only have two boundaries. We have this boundary going through the x and this boundary going through the y. So when we talk about domain, remember domain is x, so left to right, something is less than x is less than something. So, and it is always left to right. So my left boundary going through my x-axis is -2. Now this is a closed circle, so remember that closed circles are going to have that extra line, extra coloring, extra line, and then I don't actually have a right boundary. So I can write my domain as -2 is less than or equal to x, or I can flip it around and I can do x is greater than or equal to -2. So when I look for my answers, this is going to be my domain. So make sure you pay attention because you also have x right here. You have x is greater than -2, but there's not a line. So that one is not going to work. For our range, same concept. Something is less than y is less than something. And now we're going bottom to top because it's always going to be least to greatest. So my bottom boundary is 3. My top boundary is infinity, and it is a closed circle. So again, we're going to put our line. So we can write 3 is less than or equal to y, or we can flip-flop it, y. Remember, if you flip-flop it, you have to flip-flop that inequality. So this one is going to be our range. And again, pay very, very close attention because this one, it looks the same, it just doesn't have the line. Number 2 talks about writing a simplified expression that would represent 24a to the 11, b to the 3rd, all over 4a to the 4th, b to the 15th. So remember, we don't have to distribute. We don't need to put any extra ones. Regular numbers, regular math. So this is just going to be 24 divided by 4, which is 6. And we learned that when we are dividing, this divide is like a big giant subtract. So A11 minus 4, which is 7, and that is a positive. And then B3 minus 15, which is a -12. So 6 and the A are positive. They're going to go on the top. This is a negative. It's going to go on the bottom and become a positive number. Now you can also pay attention to when you're doing with your letters up and down. We have more A's on the top, so that 7 is going to stay on the top. We have more B's on the bottom, so that 12 is going to go to the bottom. On number 3, you want to read real carefully, pay attention to keywords. Health scientist studies the outbreak of contagious virus. Function 900 times 0.85 to the d gives the number of people who test positive for the virus on d days after an outbreak. Circle the correct answer for this statement. So the number of people who are initially, keyword, initially infected. Okay, remember this is A and B, and your initial amount is your A. So our A is 900. The number of people who test positive, is it increasing or decreasing? So that we are going to be looking at the B value, and the B is less than 1, so that is going to be decreasing at a rate. So this is where we got to pay attention to what we're writing. Rate is R. So remember, for your rate, 1 plus or minus the rate gives you your B. Now this is decreasing, so we're going to have to subtract 1 minus something is 0.85, which is my B. So 0.15 is going to be my R. So we are going to be decreasing at a rate of 15% each day. Remember, decimal to a percent, 2 to the left. If you have percent to a decimal, percent, decimal to a percent is 2 to the right, percent to a decimal is 2 to the left. So you have another one like that here. So remember A and B. This is talking about insect population after X months. The initial number of insects, that's going to be your A. Now, your B on this one is bigger than 1.3, so this is increasing. And again, the rate, so we're going to say it's increasing, so 1 plus the rate gives us that B of 1.3. So my rate is 0.3, and I'm going to move it over twice for 30%. Remember, rate and B are two different things. The table shows the value in dollars of the motorcycle at the end of X years. Which exponential function models this situation? Okay, it does tell us it's exponential. We can see that in our equation. So you can put this in list-in spreadsheets and do menu for 1A. This is what it looks like in main. So that's going to be this. So then after 7 years, so this is years, remember, is X. So you're going to have to do 9,000 in your calculator or in Desmos times 0.9 to the 7. And when you do that, you get 4,304.67 cents. Desmos, so you can see here, I've got A is 9,000 and B is 0.9. The table represents some points on the graph of an exponential function. Again, exponential, so this is going to be menu for 1A in our yellow calculator, or you can use Desmos. When you plug that in, is 1.2. Now, we are having, our B is going to be in fractions here, so I know it's not these two. So I can put 6.6 over 5 into my calculator. It is 1.2, so that's going to be my answer. If I do 5 over 6, I get 0.83. So make sure you double check your fractions in your calculator. Company currently has 120 employees. That's going to be our A. The number of employees is expected to grow. So we're going to have 1 plus something gives us our B. And it's going to grow at a rate of 7%. So when we plug this in, 1 plus, move this, make it a decimal, 0.07 equals 1.07. So that's going to be our B. So A times B to the power of X. The number of pufferfish since 2012 can be modeled with the exponential function graphed on the grid. X is the number of years since 2012. So 0 is 2012 and then so on. Based on the graph, which is true. Since 2012, the number of pufferfish has gone up by 50 each year. Okay, well, it did go up by 50 on the first year. If I made a little table of 0 and 100 and 1 and 150, but then I can see it too, it is above 200, so that is not true. The pufferfish increased by 100 in 1 year. No, this is only going up by 50 in 1 year. Every year, the pufferfish increased by 25%. So you can take this, you can do menu for 1A and put this into list-in spreadsheets. It's going to tell you that the A is in fact 100 and the B is 1.5. So that is not 25%. And the pufferfish started at 100 in 2012. Yes, that is true because it does tell us that 0 is 2012. The population of pine trees, the 200-acre area, has decreased roughly the same percent over the last 4 years. Table shows the data for the population after T years. Write the exponential regression. Okay, so this is menu for 1A to fit the model function. Which function models the population of the pine trees? And it says in T years. So again, we can put this into our calculator, our yellow calculator, or so when I go back, 116 and then 0.87. So here's the thing. that would be this answer, because if I check that fraction in the calculator, it does match this decimal. If you do this in the yellow calculator, which I did do earlier, and that's on the PDF answer key, I got this one. So I would take either of those answers on this. I'm not really sure why it came out different. And here's what it looks like. And you can see here, here's my A, 18, my B. You can put the into Desmos, which you can see that I've done here. Now, 1160 and then 0.872. What is the asymptote of f of x equals 3 times 2/3 to the x? So remember, this asymptote is the number, or the equation, and it's a horizontal equation always, that the graph gets really, really close to. So this is a y equals equation. So I would definitely graph that in Desmos. So it was y equals 0 or x equals 0. I would definitely graph that in Desmos so you could see which line you are looking at. For the next one, same thing with the y-intercept. The y-intercept is the a. If you were unsure, then you could definitely graph this in Desmos and double check it. All right, sequences. So a sub 1, we talked about this. That means that our first term, because remember, sequences start with 1, not 0. My first term is 6. Now, this is a little bit different. Notice this says 4 times. So that means our pattern is times 4. So 6 times 4 is 24. 24 times 4 is 96. And actually, at that point, we could actually pick our answer. You could keep going if you really wanted to. 96 times 4 is 384. So you just have to look at how it's written. There's no plus sign there or minus sign, so we know we're going to be multiplying. So another one where we need to make a table. This gives you, remember, the little number is your x, and the big number is your y. And we can... not 3, I apologize. This should be a 3. And -1, 4, and -3, and then 5, -5. Now you can do, because if you look at all of these answer choices, these are linear. So this is menu 413, like we've done since 8th grade. You could also put it into Desmos, and when you do, so make sure you pay attention. Notice that C has them flip-flopped. And then D has -2, but it has a -5 instead of a +5. So be very careful there. Write the equivalent expression. So we're going to make sure that we put 1s when we don't have any, especially when we're needing to distribute. So always put your exponent of 1 first if you don't have it. Then we want to distribute. Now this 1/2 is outside the parentheses, so I'm just going to write it out here. Because it's not being distributed to. So remember, when we distribute, we're multiplying. 1 times 2 is 2. 4 times 2 is 8. 1 times 2 is 2. There's nothing out here to distribute. So we're just going to go ahead and we're just going to rewrite 3. You can put the 1 if you want. X to the 7, y to the 5. So now we need to just go down the line. We have regular numbers, regular math. So I'm going to say 1/2. Don't forget the squared on the 4 times 3. When I put that in my calculator, I get 24. Make sure you put the squared when you do that. Then we're going to combine our variables. So I have x's, I have 8 x's, and then I have 7 more. Remember, if they're in the same line, we're going to add them. And then the same with the y's. 2 plus 5 is 7. These are all positive, so we have no denominator. X to the 15. Y to the 7. Here is what it looks like. And you can see right here, this is the line that we're going to get super close to. That asymptote is actually called y equals 0. Now, if you were not sure if that looks like you, look 5 like this. So you can see right here, I graphed it, and then I found where it crossed the y-axis, and Desmos will mark that. So it's like this. So you can see my M is -2 and my B. Last page, what is the graph of this function 4 times 1/2 to the x? I would most definitely graph this in Desmos to see what it looks like. Even if you're like, you know what, I know this is my a, which is great. I'm glad you know that. Make sure when you do this in the computer, we have to click the type of graph. This is exponential, otherwise it's not going to draw your line correctly. Click 2 specific points. They cannot be decimals to draw that graph. So when I graph this in, when you do this in the computer, definitely start with that y-intercept. And then we also had 1, 2. It's not going to let you add a second one, but if you've clicked exponential and you put those 2 dots, it should draw your graph like this. And it's also going to put a dotted line. I do believe it defaults here. I'm not for sure. You'll have to look. That is going to be your asymptote. If the asymptote is not at y equals 0, you're just going to have to click on it and move it up and down. Which expression is equivalent to 4 on the square root of 63? We did this before break. 63 is 9 times 7. We talked about breaking into our primes. And when you do that, our pair goes outside. I already have this 4 outside, and I need to make sure that I put my pair out. So times, we only write it once, and our singles stay in. So 4 times 3 is 12 on the square root of 7. I would suggest that you check this in Desmos. Area of a rectangle represented by the expression, and then we have the length, and we want to find the width. So remember, area of a rectangle is length times width. If I want to find the length, I'm going to have to divide. So if I do 25, a to the third, b to the 7, all over 5a, I'm going to add my 1 on that because I'm missing an exponent. And then we're just going to go through the steps, right? Regular numbers, regular math. So I can do 25 divided by 5 is 5. Do not write 20. We are not subtracting that. Then I can look at my a's. I'm dividing, so I know I need to subtract is a 2, only because those are exponents, right? We don't subtract our regular numbers. So I get positive exponents, so my answer is going to be 5a squared b to the 5th. Last one, you're going to need to put a 1 on that 81, and you're going to need to distribute. So let me make that, it's not going to let me delete it. It's a 1, so we'll go with that. We're going to distribute here, here, and here. So I have 1 times 1/2 is 81 to the 1/2. 14 times 1/2 is 7. You can also use your calculator for that. 6 times 1/2 is 6. Definitely put this in your calculator. 81 to the 1/2 power is 9. And then we don't have any more x's or y's to put together. So we're just going to write that. I apologize. I just realized that this should be a 3. Half of 6 is 3. Please be careful with your steps. This is what it looked like. And I clicked the little cog here and I clicked table. So I can see exactly, I have these specific points. So here you can see that I put the original and I put my answer and my decimals match. So that is definitely what we want.